So up to this point, we're only been looking at descriptive statistics or univariate statistics, where we look at one variable at a time. Now we want to kind of move or shift to bivariate statistics, which is going to require two or more variables at a time. And we can look at correlations or inferential statistics with that. Correlational statistics are used to describe the relationship between two variables, how one variable affects the other. So popular correlation statistics are the Pearson product moment correlation coefficient, usually referred to as the correlation coefficient, or R. We can look at positive correlation, which is as one variable increases, the other variable increases, or if one variable decreases, the other one decreases. So they move in the same direction. Or we can look at a negative correlation, as one increases, the other decreases, or vice versa. So they're moving in an inverse relationship. We can also look at how strong the correlation is. And so R can range from 0, which is no relationship, to 1, which is a perfect relationship. And here's a little table to help guide you for interpreting the strength of relationships. So if we're looking at 0.6 and above, we're looking at a pretty strong to a very strong relationship. With 0.4 to 0.6, it's a moderate relationship, and anything below that is a weak to non-existent relationship. We can also look at the coefficient of determination. So this is when we take the R value and square it. And this tells us the amount of change in one variable that is accounted for by the change in the other variable. An example of this would be the relationship between the number of hours of practice in winning basketball games. So we look at 0.73 as a strong relationship, and our R squared, which would be 0.73 times 0.73, which would be a 0.5, is our coefficient of determination. So if we look at here, at the interpretation of this, we'd say 53% of games won can be explained by practicing a lot. And conversely, 47 of the losses are explained by something other than practicing. Let's look at a quick example here of interpreting direction and strength of correlation coefficients. So we're looking at a coefficient value of 0.35 between leisure time physical activity and physical functioning. We can see here that it's positive in its direction because there's no negative sign in front of it. And we know, because of our scale we used earlier when we were looking at how weak or strong it is, that it's a weak one because it's below 0.4. So we can say there's a weak positive relationship between physical activity and physical functioning. So as physical activity and leisure increases, our physical abilities also increase slightly. So we say slightly because it's weak. Then we have negative 0.68 between amount of television watched and the number of best friends. So it's a negative relationship. So as one goes up, the other one goes down, or vice versa. And we know from our previous table that we know 0.68 is a strong relationship. So we can say there's a strong negative relationship between watching TV and having friends. Or individuals who watch a lot of television tend to have fewer friends. We're going to talk about inferential statistics for just a quick second. Inferential stats is a family of statistics that tells how much confidence we have when we generalize from a sample to a population. This includes things like t-test, ANOVA, and chi-square. And the easiest thing to do is say you'll need to use a software package to calculate this. But overall, let's think about it like this. We're going to sample female and male students to measure their physical fitness. We got a whole lot of people, and we separate them between male and female, and then we measure their physical fitness. Oh, guess what? We found a difference in physical fitness between the two groups. Inferential stats will help us determine if that difference that we found was just due to sampling error, something we did wrong in how we sampled, or if there is a real difference in physical fitness between males and females. So overall, people use statistical software to do a lot of this stuff. So a good example of this would be stuff like Excel, SPSS, SAS, and R. So depending on what kind of professional circle you're in will depend on which ones you use the most often. Now, out in the professional world, away from academic and research, Excel is probably the most popular one. And you can use its functions to help you determine some things like average, mean, median, mode, stuff like that. And it'll actually do some more advanced stuff if you have the training to do so. Most of the people that do the advanced stuff, like the inferential statistics, will look at stuff like SPSS and R, and both of those are pretty darn popular in academics and otherwise. Remember, human intelligence is needed to choose the correct stat program. So while the stat program and having a computer can help you get there, you got to understand what you need in order to run the right statistical analysis.